Good evening, everyone. Am I audible?
Yes, sir.
Okay. So while this is joining, I left the last session with a question. Does anyone remember? Okay. So I'll repeat the question. The question was, why NumPy operations with NumPy library, especially NumPy arrays, are faster as compared to stock operations?
Because NumPy arrays only contains homogeneous elements, so compared to the Python list, which can have different types of elements in the list, which makes the computation easier. And also NumPy is written on C, so as C is faster than Python, so the NumPy arrays are also faster.
Okay, both reasons are spot on. First reason is, yes, the data structure that is used for list is a collection of heterogeneous items, while NumPy arrays are always homogeneous, and that's why we can write optimized code for NumPy arrays and not for lists. Absolutely. So those two are the reasons because of which NumPy operations, NumPy matrix operations, will always outperform in terms of the speed similar code written in using Python lists. Okay. Now let's start with the practice programming questions. Then we move on to solving the question. Okay. Before we move forward, any questions? All right. So let's read this one.
Like, can we
yes.
libraries in this sklearn libraries in this programming thing, OP,
Pardon me, I can't hear you. If
So-
typing a question.
Can we use libraries like sklearn in this? Like,
Good question. So in ML techniques, all the assignments as well as the proctored exam, we'll be using NumPy and SciPy only. Will not use sklearn library.
so we're not allowed to use any library. So we have to make the code ourselves. Like,
You're not supposed to use sophisticated machine learning libraries like sklearn or TensorFlow, Keras, or anything like that. You can though use NumPy, and definitely we will use NumPy, SciPy.
okay.
And yes, you will have to write some of the algorithms or some of the procedures that take the course. We will be implementing those with the help of NumPy from scratches. Does that answer your question?
Yes, sir.
Okay.
Sir, I have another doubt as well. Sir, when
Sure,
we give random states in a program, we give, I've seen multiple numbers being given like 42, 36. What does that signify? I mean, each of those numbers. 42, I know that it gives us the same data set again.
Okay.
So like that, how many are there, or what each of those numbers signify?
Okay. So, the random number generators in any language are actually pseudo-random generators, pseudo-random number generators, because it's not like they don't take any input. What they do is they do take some kind of input. For example, the machine on which they are running, they take the timestamp of that machine while at the time of invocation as input, and then generates a random number. So it looks like that it is generating pseudo random numbers, but it is generating pseudo random numbers. So if you want, for the sake of experimentation and for the sake of reproducibility, what we do is we fix any number. So 0, just use any 42, 1, 32, 100, 1000. As long as you keep using single seed number, your results will be reproducible. So if you share those, share your collab with your friends or colleagues, or you publish your results, somebody wants to check it, then that would be easy.
Okay, so does that mean that any number I could use instead of a 42, I could use a 32 or something like that?
Absolutely, any integer.
Okay, okay, fine, fine. Okay, sir. Thank you.
Sure. Okay, so this first question, write a function add _1 x to include first column with all elements 1 x. Okay, inputs a matrix x, output updated matrix with the column having elements 1 added as the first column to x. Okay, so is this question clear? I have received an answer also from Aisha. Okay, please, this is solve it instructor session. So please type in your answers and paste it in the chat box. We'll discuss those. Take a couple of minutes. Okay. Mahek, you are using SQL library, which is prohibited for machine learning techniques course entirely. There are a few things for which we will use SQL library, for example, splitting the data and small things like that. But apart from that, we are not going to be using SQL library. So please use NumPy and SciPy.
But just in case, because we are doing 2 courses at a time, if in case we make such a mistake out of maybe confusion or whatsoever, so will the marks be deducted for that?
Yes, absolutely. If you solve the problem with the help of SQL, you will test cases might pass possibly, but you will not be rewarded marks for that.
Okay, okay.
So please keep this point in mind. Main theme of machine learning techniques is implementing, understanding the algorithms from scratch. So looking inside an algorithm, looking inside a model, not just using it, importing it from some library and just making use of it. That's the focus of machine learning practices. Okay, I have received a few more answers. Indraneil, Rahul, Suyash, okay. Vivek, yes. Okay, so I have received a few number of solutions and they look very promising. So let me try Vivek's solution while others are still typing in their answers. Okay, so Sabit has also submitted his answer. Okay, so Vivek is making use of column stack function in NumPy. Okay, so what it does is the first array that you provide to it adds that as a column to the next array, and this should be your answer. Okay, so I think this should pass. Great. Test cases are passing. Public test cases. Let's try them. In test cases as well. Yes, all of them passed. So great job. Submit your answer seems also good. Yes, I think you can use numpy.c underscore also. Indraneil, yes, same answer. Yes, actually, the answer seems great as well. There's one different kind of answer submitted by Suyash. Let's try that. So Suresh, it seems like you are not using NumPy. Insert. Okay. For I in X, I is equal to NumPy dot insert I comma 0 comma 1. A dot depend. Okay. So I'm not sure, Suresh, it should pass all the test cases. Okay, it is passing all test cases. Okay. Suresh, even though it is passing all the test cases, can you tell me the type of A? What will be the data type of A? Or anybody can tell me data type of A?
List of lists.
List of NumPy arrays.
List of NumPy arrays.
Right. So this is not desirable in this situation. This code work, but this is absolutely not desirable. Writing NumPy operations as a form of for loops, absolutely not. Okay, so first it takes a lot of coding. It takes on your part or the programmer's part to write a lot of code, which has higher probability of having bugs. If there are more complex operations, you would have to write more number of loops. If else will be involved, so the code will look more complex. When you can do the same thing simply with some NumPy operation, some NumPy API. So it's recommended that do not use for loops, just use NumPy operations. Second, the output of this one is going to be list of NumPy arrays. For this particular exercise, it passed, but some of the real situations you might encounter in which the output should also be a NumPy array. So either you can easily convert it to a NumPy array. But if you just use NumPy API, then the output will automatically be NumPy array. Okay, so the conversion won't be necessary. So just keep this point in mind. Always use NumPy operations whenever you are dealing with devices. Okay, so let's go to next question. Any questions so far up to question number 1? All right, let's go to question number 2. Write a function multiply x comma w to multiply feature matrix x and weight vector w after addition of dummy feature. The inputs will be feature matrix x and w weight vector w. The output will be product of x and w after adding dummy feature to feature matrix x. If the dimensions are not consistent, return none. Please type in your code and paste it in the chat box. Soumya has written her answer. Sabit has also done the same. So Rahul and Asha have also submitted their answers. Okay, correct. The answer is also there. Okay, let's try Mehak's answer. Okay, so what is there? First of all, we are going to need another matrix which has the columns of one. The first column inserted, all the elements of that column are original matrix. So this one, the A matrix will have an extra column. Okay, then after that we are making sure that this new matrix A and the weight vector, both of them are compatible to be multiplied. If yeah, then multiply them and return the answer. Otherwise, return none. Great. So let's see. All public test cases passed. Right. All private test cases also passed. Great. I want to try out one more. Devipriyo is also mentioned his answer. Yes, Devipriyo, your answer seems also be correct. Aisha, Sabir, Soumya, all your answers seem to be correct. Okay. I want to try one code that Rahul has submitted. Okay, I think you are making use of the fact that if you don't write anything, it returns that. Okay, okay. So you didn't write explicit then none is taken. Okay, this answer is also. Any questions so far?
Just a quick question. So professor seems to use assert quite a bit.
Yes, yes.
Will that work here also? Like, can we use none as an output in case assert fails?
No, actually. So when assert fails, it will generate a runtime error, runtime exception actually. So that's a bit different. So yes, what you can do is, if you want to use it like that, you would have to do something like, let's say, we write it as using assert. Okay, so whenever this condition is false, this condition is false, it is going to generate a runtime exception.
You say comma none, is it? Instead of a message. Can we say comma none?
Comma none. Okay. Let's try that. I didn't try it. Maybe it will work. I don't think it should work. It will work. First, it will generate a runtime exception, and the message will be none. See, one of them passed.
Okay.
So the output is none because that's what we written here. So it printed none, but that's not is expected, right?
Yeah. Okay, understood. And assert is a inbuilt function of Python, is it? Not of NP.
Pardon me?
Assert is an inbuilt function of Python, is it?
Yes.
Okay.
So assert basically is used to make sure that you don't have to write a lot of if-else code, and before running any method or even in the code, you want to make sure that certain conditions hold true. You can write assert. So whenever you see assertion error, then you can be very confident that there is something wrong with the input that is being received by the code or the procedure. instead of looking inside the code. So that means the preconditions of running a procedural function are false, and that's why you're not getting the right answer. So it just alerts you whenever the assertion of certain conditions that are necessary for the code to run properly are not holding.
Okay, thank you.
So any questions? Any other questions so far? All right, let's move on to question number 3. Write a function loss x comma w comma y which takes feature matrix x, create vector w, and output label y, and returns the sum squared loss while implementing the integration model. Note: do necessary pre-processing x. The input of your function should be feature matrix x, weight vector w, and the output label vector y. The output will be sum squared loss if dimensions of inputs are consistent, otherwise not. I have started to receive answers. Soumya has written an answer. Vivek has also published his code, so let's submit. Ranjit has also listed his answer. Smita also has submitted her answer. Aisha has also entered. Okay. So let's try Smita's answer. Okay. So first step is to add dummy feature. Okay. You add a dummy feature and still the name is x. Okay. X dot shape. You are checking that the dimensions of x and w are consistent. And after that, okay, in the single line you are computing x at the rate w, which is prediction minus counter. This quantity is error vector. Transpose of that with the same error vector and multiplying by the half. So I'm going to write this. This is absolutely correct. I'm going to write it in a different manner so that the names of the features are a bit more clear. sorry, names of the variables are a bit better. And so W minus Y and this, so it should be okay. So this is a bit more just better on readability side, but Manasuta, your answer is absolutely right as well. And the everybody else who has written, yeah, thank you. I suppose. And thanks Amit for correcting me. And everybody else who has written the answer, I think all of your answers are also. Right. Now let's check this out. Okay. All test cases passed. I think we have successfully gone through all the programming practice questions. Any questions so far?
So for OP, the questions will be like this only, right?
Yeah, exactly. Okay. Now let's move on. Solve it. Set the session. So I have prepared a set of questions which are very similar to what has been done in the as well as in programming assignments. So we'll go through them one by one. So, I hope it is visible. Okay, so first question is, what is supervised? Out of the two, the labels are available, the labels are absent. Which one of them? The correct answer?
First.
Pardon me?
One.
First one. Absolutely. Question number 2, what is regression? The label is a real number, the label is category.
Option 1.
One.
Absolutely. First one is still the correct answer. Now, we are going to perform regression, and for that, we are going to generate some random or toy data set. So, this is the description by which you will have to generate random numbers. Use NumPy library to generate 100 uniformly distributed real numbers in 10 to 60. Add random noise generated by adding 100 random numbers generated from a standard normal distribution, or I should change it a bit. Instead of a standard normal distribution, normal distribution I think its standard deviation should be, let's say, 50. And mean should be 10. Okay. So use this as random number noise generator. And after generating the uniformly distributed numbers, adding the noise, this will become your input feature. Use the seed is equal to 1 for generating random numbers. Produce output y is equal to mx plus c, where e is the noise in the data, and m and c are 3 and 4 respectively. So take 5 minutes and write your answers in the chat box. Okay, so I'm not seeing any answers from anyone. Is this a difficult question? Are you having some kind of trouble? What's happening? Hello, am I audible?
So how to put the random the seed number in this, because I'm using random dot normal. I can't see
Okay,
where I can.
Okay, so whenever you want to, so this is not connected. Random dot seed equal to which number is being 1. So by this you can actually yeah, so something like this.
Okay.
Now,
Okay.
NumPy dot random dot c.
Okay.
So what is that seed for?
Pardon me?
This actually, what is that seed meaning?
Okay. So the meaning of the seed is, a few minutes back we discussed that the random generators in programming libraries are actually pseudo-random number generators. They still need some kind of input. Right? So if I don't give an input, right now what I'm doing is I'm generating a number between, let's say, 0 to 9. Any random number between 0 to 9. Every time I call it, I'm going to get a different number. 7, 0, 2, and so on and so forth, right? But in order to reproduce use the randomness in my experiment, and still want to make sure that the experiment is reproducible, I put some seed number. Okay, so if I do this, if I put 1 over here, and even if I run this hundreds of millions of times, I'm going to get the same number, same output.
Okay, once the random number is generated, it will be always the one related to it. It is always equal to that one set of data.
Yes, the procedure becomes reproducible. So if I use this one more time, now I'm going to get a different answer.
Okay.
But if I keep executing these set of statements after setting the seed 1, I'm going to get the same answers across different experiments.
Okay, thank you, sir.
So can we use linspace?
Yes, you can use it will be better if you use linspace. Okay, so let's try solve this problem one statement at a time. Okay, so first thing is generate 100 uniformly distributed real numbers between 10 to 60. Okay, so let's call it x is equal to numpy dot linspace 10 comma 60 comma 100. That means I want 100 numbers starting from 10 ending at 60. I need both the numbers, both inclusive, that is. So if I execute this one and print some of the numbers, let's say I'm just print first 5 numbers. Okay. So sorry, not first. This is first. So the first number starts from 10. The second number is this one. The third number is this one. So how would you check that they are uniformly distributed? You can just simply subtract consecutive numbers and see if the result, if the difference is coming out to be the same. So difference between first and second number is this much. I think it should remain the same for the second and third number. It is still the same. So you can do this. Linspace actually generates equally uniformly distributed numbers. So what you tell it, what arguments does it take? First is starting point, the ending point. Both of these are inclusive. Both of them are included, and the number of randomly distributed points. If I keep it 101, difference will come out to be 0.2.
So we can also use np.random.uniform.
Pardon me?
np.random.uniform we can also use.
Can you speak a bit louder?
np.random.uniform, sir. And we also
Random dot
uniform.
Uniform. Okay. Yeah, you can use that also. Okay. So now we have done first statement that we have generated 100 uniformly distributed number 60. Now next task is add a noise generated by adding 100 random numbers from a normal distribution with mean and standard deviation 50. So for this one, we will be using, there are a couple of methods to do this, but I'm going to use numpy.random.rand n. So whenever you want to generate random numbers using NumPy libraries, all of them are situated inside package or module and numpy.random. Okay. Inside this, I'm just I have to tell it how many numbers do I need. So it will always generate random numbers from a uniform, standard normal distribution. So if I write 5, it's going to generate a NumPy array of 5 normally randomly and generated numbers from normal distribution. But the question says that the standard deviation should be 50 and the mean should be 10. Any ideas? By the way, we are not going to be generating just 5 numbers. We will need 100 numbers. Okay, and we will generate 100 numbers. Let me call it noise. Okay, but this noise must have 10 mean and 50 standard deviation. Can anyone tell me how to do this?
So you have to create a function in which
Okay.
you will return mx plus c, and then you will add the noise to that answer.
That's true. That's true. So this is noise. Y is what I want. Okay, and before I go to y, I'll write n comma c is equal to 3 comma 4. Right? So I have initialized my m and c. Now what I want is y is equal to mx plus c. N star x plus c plus my noise. But this noise is supposed to have 10 mean. How can I do this?
So generate between minus 40 and 60.
Pardon me?
Or generate between minus 40 and 60. Is it?
This is the numbers. This is this. So we are generating. Think about this. We are generating the noise from a standard normal distribution with a standard deviation 50 and mean 10. How can we do this? So now we know that this is a standard deviation. Sorry, standard normal distribution. This is how we are going to use it. But can we, do some mathematical operation and convert this standard normal distribution to something that we want?
So, but here you will use random dot normal.
Pardon me?
So you will use np dot random dot normal, and in bracket you will write standard deviation and the size of it to get the normal distributed noise.
Absolutely right. This is one way to do it. Can we modify this one? So Shailesh has put in his answer, and I think Shailesh, your answer captures the correct logic. All we have to do is we want to shift the mean of it, right? So whatever the number, we just add it to 10. And whatever the standard deviation is, we multiply that with that number. So this is equivalent to, I think, noise is equal to NumPy dot random dot normal. In bracket, you will say the mean, standard deviation, and the number of points you want. So both of the two statements are going to give you the exactly same results. Okay. Now we have done. We are clear with the logic. Let's print some of the values of. Okay, this is what is coming out. The solution is not exactly right. It's a bit different. Don't worry about it. Okay, so any questions so far? Is everyone clear on how did we get this answer? Okay, let's use the.
Can you explain the noise part again, sir?
Sure. So, for example, even normal. This represents your standard normal distribution, right? Hello.
Okay. Can we use the random dot normal here also?
Yeah, of course. I told you that this statement and second statement, they are exactly same. You're going to get the same results. Okay, note this. For example, the first value is 52, second is 42, 44.
No, but
okay.
Here we'll have to put the range, sir. We'll have to put a tuple 10, 60 instead of 100.
Okay. So see, whenever you are in doubt, always look at the documentation. Okay, NumPy dot.
Okay.
See, location is mean, right?
Okay.
Scale is your standard deviation.
The standard deviation, right?
Size is how many numbers. You can give it a matrix also, like 100 by 100 or 20 by 20. I just given 100 because I just want to write that. Okay.
Can we give a range also?
The range? No. Why? How?
Because we want only from between 100 and 16, 10 and 60. The distribution.
Yeah. 10 and 60 was for uniform. For normal, it is for 100, I guess.
Okay.
All right. So see, both of these are going to give you same answer. I've written 5 over. I should write 5.
Sir, I have one question. Even if for random, if we have range, for suppose if there is a range between some 10 to 100 or something like that, how can we apply that?
Range to noise?
Yes.
Similar
like suppose this is for 100 numbers. If I have some range instead of just 100 numbers.
Can you give an example?
Like 10 to 60. Like what we have done for the normal uniform. Similar, if we need to generate between some range.
The random numbers between some range?
Yes, for normal.
Yeah, you can absolutely do that. You will have to apply scaling. Right. So what you want is the noise that you receive from this function should belong to range, let's say 50 to 100 to 200, something like that.
Yes.
Okay. So what you'll have to do is you'll have to scale the noise. Let's say 100 to 200, right? 100 plus. Have to do some kind of scaling. Are you aware of min-max scaling?
Yeah, I've just seen the video, but I haven't practiced yet.
Okay, so what you'll have to do is NumPy dot whatever the number is, noise actually. Noise minus NumPy dot minimum of noise. This whole thing divided by NumPy dot max of noise minus NumPy dot min of noise, and this entire thing should be multiplied by 100. Now your range will be so instead of writing 100, I am going to write it 200 minus 1 minus 100, so that this is a bit clear. Does it make sense?
Yep. Okay.
Okay, so what I have applied is typically min-max scaling returns you the answer between 0 to 1, right?
Yes.
So whenever the answer of so this is min-max scaling. So whenever the answer is let's say 0, this entire thing becomes 0 and the answer is 100. So lowest value will be 100, right?
Right.
And this quantity will give you the highest value. That is going to be 1. When noise, the element in noise is equal to numpy dot max, the maximum value in the noise, right?
Yes.
Then this quantity will become exactly 1. 1 multiplied by 100 is 100, and this entire thing will become 100. 100 plus the first 100 is 400. So your range will become 100.
Okay. Okay. Got it.
Okay. Something which is not necessary as of now, you will study impacts scaling in practices. So, any questions so far? What we have done in this?
So can you explain this seed dot seed function?
Which one?
So random dot seed.
Random dot seed. Yes, this function is only used to set the seed value that the random number generator is supposed to take in order to generate any random number or set of numbers.
This is basically for replication. So if I put seed 1, I'll also get the same array as what you've got.
Absolutely right. Absolutely right.
Sir, the first noise function you have written, is it coming from the standard normal conversion formula, x minus mu divided by sigma?
Okay. This one,
Yes,
which
yes.
is okay. Yeah, it is coming from standard normal distribution.
Okay. Okay.
Right. Any further questions? Okay. Okay. Since there are no further questions, proceed with the next question. Question number 2. Make a scatter plot of the data to visualize it. So whatever data that you created. So I hope that you have written this inside your collab or inside your editor, any IDE, and you are working with me, because the next set of questions are dependent on this one.
Sir, it is 10 plus 5 into or 50 into?
That's fine. I have written 10 plus 5 so that the curve that we are going to drawing, next question, look a bit smoother. That's it.
Okay, so initially you said it's 50, now changed to 5, is it so?
Yes. All right. Going to the next question. Task 2. Make a scatter plot of the data. So take 2 minutes, and I think this is a bit easier than the first question. So take 2 to 3 minutes and write your answers in the chat box. Okay, I have received answer from only Shailesh so far. Okay, so are you guys having trouble answering this question? I mean, these kind of question I'm seeing bit delayed answers as well as less participation from you guys. Are these questions difficult, or you are having trouble with NumPy, or
Not very clear about these all graphing and all.
all right? So basically, what you're saying is PyPlot is new to you.
Yes, sir.
Okay, good. So I'll explain a few things about PyPlot. I'll try to cover it is that it should be for somebody who is looking at it for the first time. Okay, so let's make a scatter plot. So I've received some of the answers. Aisha has posted an answer. Devapriyo, Mahak, Shailesh. I think all of your answers are correct. So let me go through PyPlot one statement at a time for those who are seeing it for the first time. So PyPlot library sits inside the Matplot lib library. So earlier there was PyPlot actually came later. So it's a child of Matplotlib. Earlier it was Matplotlib, which was used primarily for graphing purposes or creating charts. Now, whenever you want to create a figure, basically something to draw upon, so that's called figure. Okay, so yeah, right now it is showing figures object has been generated, but it is not being shown because it is empty first of all. And if you still want to show it, you want to write it clearly.show. Okay, it's not showing the empty. It's all right. We'll come to that. Next, whenever you draw something, you give it two set of coordinates. One is x coordinates, and the second is y coordinates. So we have these coordinates. X will become, so whatever we generated over here, x is our x coordinates, and y has the corresponding y coordinates of all the points in x. Okay. So whenever you want to plot something, you give it x and y coordinates. So there are different types of plots. So right now the one that we are going to use is scatter plot, x comma y. So it makes sure that the points are plotted in the form of disconnected points. See this one. So this is the output we get. From on x-axis, you see the range is from 10 to 60. On the y-axis, you see range from around 40 to 200, something like that. Just coming out of this formula itself. So you can see that 60 multiplied by is 180. plus 4 is 184. So yeah, so the highest point would be a bit lower than 200 or around 200, depending upon how much noise is added. So this is our data. Okay, Kanika has also pasted an answer. So any questions so far? How did we do this?
So we can use Seaborn as well as Matplotlib both interchangeably for drawing charts.
Yeah, you can do. You can absolutely do that. Both of them are freely available libraries. The names of the functions are a bit different, and how you call it is also different. So they take different parameters for doing the same thing. And Seaborn is a bit more powerful. Not powerful, I would say. Seaborn has some set of functions or APIs which will allow you to create beautiful charts. Not that you cannot do that in PyPlot or Matplotlib, but in PyPlot you have to do additional set of programming, additional code you have to write to get the same results.
And sir, I also see some codes wherein both of them are mixed as well. I mean, there are certain lines which are from Seaborn, wherein we call it as SNS, and there are some from Matplotlib.
In the yeah, that's also fine.
Okay.
Okay, so scatter plot we have plotted. Okay,
So-
Vivek has also pasted an answer.
So why that figure is for?
What is that?
Figure.
Yeah, this figure actually is the data that we generated using this formula. Y
No,
is
the
equal to mx
figure
plus
the
c
figure
plus noise.
function is
Oh, this figure function
The fi-
creates a figure object on which we can draw something.
But sir, it works without it even.
Pardon me?
It works without the figure function as well. Like we don't need figure function. It's working without it as well.
This step is not necessary. Okay, so if I remove it, it will still work. Okay, but what happens if you want to modify the property of some properties of this figure? We want to, let's say, change the size of the figure. Then you can do that by giving it a parameter fixed size and passing a tuple of the size of figure that you want. Now I have increased it.
Is it width by height, the tuple?
Let's find out. Yes, it's first width then height. Okay, so I'm going to remove it now because this is looking. Now there are a few interesting things that you can do with the plot that once you have generated. So, for example, you can place labels of x-axis, y-axis, and regions as you would do with any other chart. Would you like me to show that, or should we skip that?
Sir, can you show that?
Sure. So, for adding any text to your x-axis, you call the function plt.xlabel, okay, and put it over there. So, I'm just going to put input feature. Okay. If I execute it now you will see whatever string I passed inside this function is appearing beneath the x-axis. Does it make sense?
Yes, sir.
And similarly, you can set the y label. Output. And here you can see now the y axis is also labeled. You can also set the title of this chart. plt.title input versus output of y data set. There it is. Now you have set x label, y label, and its title. Sometimes you would rather want to, see the grids also. That means the lines, some intermediate lines, which are faintly visible. For example, BLT dot grid. Now you can see these horizontal and vertical guiding lines as well. Not only that, you can actually use, I should say, LaTeX commands. So I'll quickly show you that. I should do something. This is how it looks like. From 0 to pi. I think I should have just 2 pi. See, so this looks like a complete cycle of a sine curve, right? The thing that I wanted to show you is we can write mathematical formulas also inside this using LaTeX formulas. For example, inside the title is sine 0 and there it is. Now it is showing 0 and pi. So and instead of scatter, we could have used plot. So plot function, what it does is it draws a line between two consecutive points. Okay, so instead of 1000, let's say if I make 10, I just 10 points between this. Now you can see this jagged curve. It's not smooth because the number of samples is very small, not enough to make it smooth, and that's why you're seeing this kind of plot. And if I convert it to scatter, it will not draw the lines between consecutive points.
So this dollar and this slash pi you used is some way to give this the pi symbol.
Yes, yes. So this is standard LaTeX format.
LaTeX, okay.
So whatever formula that that is supported by LaTeX, you can write it inside a string also, and pass it along title, X label or Y label, and it will display properly.
Okay.
You can do very interesting things also. You can change the, right now the axis is looking from 0 to 1, 5, 6. But since you are plotting sine function, you would rather want 0, pi by 4, pi by 2, pi by 4, and so on, right? I mean, in terms of pi by 2, you can do that also. Something in exercise I would like to leave it for you so that you can continue the session. But this is pi plot is going to be sufficient for us to create charts for this entire course. You can of course use Seaborn as well.
Thank you, sir. This was quite helpful.
Yes, sir, very helpful.
So, do you want some kind of charting introduction in this course? I mean, techniques. This
Yes,
question
sir,
is
if it can be added, it would be very good actually.
Okay. At this point of time, I think we can add it as a supplementary material, but not included in exercise or uh, anywhere else. Will that be
Yeah.
okay?
Yeah, that
Yes,
would
sir.
be okay, sir. I mean, we can go through it and then understand how it is to be done. Because this again comes back in MLP. So again, I've been struggling in MLP with the plotting.
Okay. All right. I'll make sure that some introductory material on creating simple charts is included. And if you want to create more complex ones, there will be references. Does that work?
Yes, sir, that will be great.
Okay. Will do. So as of now, we have done with our task 2. Thank you for allowing me to quick introduction to plotting simple plots in pipeline. Now let's go to question number. Okay, this is how it looks like. 10 to 60. It is using, I think, a bit different noise, but that's fine. Ignore it. Whatever we did, this is our data as of now. Now, task number 3 is what, according to you, is a model in the case of linear regression. This question, I think, we have already done. This is more interesting. Let's assume that you have the weights and you are given a feature matrix. Write a function to predict the outcome. Okay, so basically what you have to do is you have to write a function which takes feature matrix X and weights and gives the predictions. I think this is something we have already done, right? X multiplied by W. Hello, am I audible now?
Yes, sir.
Hello. Okay. So I think this is what we have done already, right? X at the rate W. That was our answer. Yeah.
Yes, sir. As part of the practice assignment, we did this.
Absolutely, yes. So let's skip this for now. Okay. Now coming to next part. Geometric interpretation of the model. How does a model with one feature looks like? Line, plane, polynomial curve. It's not any specific shape.
Line.
Right. Absolutely right. Line is the correct answer. How does a model with two features look like? Line, hyperplane, circle. It does not have any specific shape.
Hyperplane.
Absolutely right. So when you have two features, the weight vector will have 3 parameters. And if you draw the loss function in 3D, you will get a hyperplane. Okay, task number 4. Write a function plot model that takes in weights W0 and W1 as input and plots the model between range 1 to 100, both inclusive. I'll keep this code in your view to help you. How would you accomplish this one? So basically, what we want is this. Okay, I should copy that over here. Yes. Write a function plot underscore model that takes in weights W0 and W1 and plots the model between range 1 to 100.
The x is the same as the before x we have created.
Pardon me?
This x is the same as the one we created before.
Yes, yes. But this time we are putting it inside a function. Right? And setting the range from 1 to 100. So earlier 10 to 60, it was provided in the question itself, right? And we did not create any specific function. Yes, you can actually modify tasks 2 to this one to create an answer for this.
So basically it is y equal to W0 plus W1 into x, right? That's what we need to create.
Yes, absolutely. Please write your answers in the chat box. So, anybody wants to share how to feel about this? Okay, I received one answer from Mehak. Hot model. One. Okay. One. Two. Okay, I'm going to copy paste Mehak's answer and see. Look at it. So this first line is doing creating numbers, generating 100 numbers between 1 to 101. I think what you wanted to do, Mehak, is 1 to 100. The number of points is 101. Then the difference between fine, just keep it 100, right? Okay, so all the points are distant and difference between two consecutive points will be 1, exactly 1. The second part is, okay, so W0 plus WX1, that sounds great. Mahat, why are we adding this 2?
Because in the question it's x plus 2.
I see. Y is equal to x plus 2?
Yes, sir.
Okay, I think for this one, what is meant is W underscore 0 is equal to 2 and W underscore 1 is equal to 1. What do you say?
Oh, I didn't know that.
Right?
Yes, sir.
Okay, so we can remove this 2 from here and this looks okay. Plot is scatter plot x comma y and show. Great, I think this should work. So now W0 is 2, W1 is 1. Let's see how our plot looks like. Fantastic, this is how it looks like. It has a slope of 1, so no surprise that this is actually a line of 45 degree, 45 degree inclined line. So this looks good. Let's try it with some other lines. Maybe let's say -1, sorry, -50 with negative slope. What should be? Or just plus. Okay, it works fine. It has negative slope and it starts with 50. Y-intercept is okay. So our function works well. Any questions so far?
There's no need to put any noise unless specifically mentioned, right?
Yeah, because the question didn't ask him.
Okay.
All it is asking is just plot a model. Let's go to task number 5. Write a function that accepts features, labels, and weights and returns loss. I think this is also what we have already done, right? Yes, I think loss is going to be y predict minus y. Yeah, fantastic. So this is we have done this one also. Let's move forward. Optimization. Okay. So optimization is a procedure by which we start with possibly a very poor model and iteratively move forward and come up to a very good model, an optimized model and possibly an optimal model. Iterative optimization is one method to solve a problem. The other one is analytical, in which we use analytical methods, some kind of mathematical formula to quickly get an answer. Okay. So the first question is, since the linear regression model is identified with the help of the weights, how do you think we should find these weights? Trial and error or using some algorithm? Anybody?
It could be both ways, right, sir?
Yes, you can do both of them, trial and error as well as using some algorithm. But trial and error is like guessing. You guess some weight vector, try it out with that weight vector, see the error if it is increasing or decreasing, and so on. So which one do you think is a better option?
It would be the second one, but even in that case, sir, we assume it to be 0, 0 and then go along doing with the learning rates, right?
Yes. Assuming that, figure out the learning rate and anything else which is associated with this. But it is still better option than trial and error because you can quickly adjust your learning rate. Within few iterations, you can figure out whether your learning rate is appropriate or not, right?
Yes, sir.
Question number 2. Why do you think using an algorithm is important? It is computationally feasible. Second, guarantees of convergence. Option number 3 is both of these.
3.
Option number 3. So if you put your procedure of optimization in a form of algorithm, to give you a couple of things. You can figure out if that algorithm is going to give you convergence or not. Can you guarantee or not? And second thing is, you can figure by looking at that algorithm, you can figure out it is computationally feasible. So yes, both of these are.
So what does
correct.
it mean by convergence? Does it mean a loss, like minimum loss? Yeah.
By convergence, what is meant? That's your question.
Yes, sir.
Hello.
Yes, sir.
Okay. So by convergence, what you mean is our answer, our algorithm stabilizes after some number of iterations. It says that there are no more. There is no need to run more iterations. You have already reached your optimized value, or very close to it optimized value. That is what we mean by convergence.
But we don't know the optimized value. So how do we know that we have reached a point of convergence?
Can you please speak a bit louder?
No, like we don't know the optimum point. So how do we know that we have reached a point of convergence?
Good point. We don't need it, but we definitely know something about that optima. That after optima, so optima is a value, but you cannot, optimize it further. Right? If you reach a optimum, for example, if you talk about parabola, okay. So imagine a parabola which is of something like, I should say, x is equal to y square plus c, some constant. Or I should choose a different answer maybe. Okay, so imagine this. Y is equal to x square. Okay, it's a parabola, right? And this parabola opens upwards. Maybe I should draw an example. Okay, so imagine, I hope my screen is visible. Imagine this is x and y axis, and your y is equal to x square parabola would look something like this. It should be smoother. Pardon my handwriting. Okay, this is how your parabola will look like, and this is your lowest point. So imagine that this function represents the loss function of your model. Okay, and you start with some random values. So you start with this kind of model. Not this kind of model, but this kind of parameters. Y is equal to x squared plus x plus, so this will be your W2, this will be your W1, and this will be your W0, right? This kind of model you start with. You are somewhere over here. Okay, and what you would do is you would compute its gradient and move towards the opposite direction. So optimum point is where the gradient becomes 0 or very close to 0, right? Theoretically, it is equal to 0. So by that, we recognize that this is the optimum point, and we don't have to do further iterations, and we can be just satisfied with this.
So we
and
don't
report
have
it as a final answer. Yes.
So we don't have to wait till it becomes 0. We can stop at 0.9, 0.5. Like.
Of course, you can stop when the let's say the error is very close to 0, not necessarily to 0.
But like, why can't we just wait for it to become 0? Like, or
why can't we?
Why can't we just like wait for it to become 0? Like, why do we need to stop? Or like, there's no chance for it to become 0? or it's like rare chance for it to become zero? Like,
Sorry, can you please speak a bit louder? Sometimes your voice drops.
so we don't try to get zero answer here. Like, is it rare to get zero, or like?
No. The gradient will become close to zero.
But it never comes to zero. Like, it's very rare that it becomes loss becomes zero or anything.
But your answer, your model will be, practically fantastic if it is close to zero also.
Yes, sir.
Right. So yeah. So we don't. So since this is an iterative method, yeah, practically it's very difficult to get zero gradient, but very close to zero gradient. For example, we can get something like 10 to the power -2 or -3 or something like that, and then we say, okay, that is fantastic. That's fine. We can stop there.
Okay,
Does it
sir.
make sense?
Yes, sir.
Okay. Coming back to our question. Right. Next question is, in this module, we will deal with two algorithms to find the weights. Normal equation and gradient descent. Further gradient descent has 3 different variations. I think that, yeah. So that is also being covered in this week itself, right?
Yes, sir.
Okay. Now let's go to task number 6. Given an array A, find its pseudo-inverse. I think the answer is also visible over there, but I would request you to type in your answers in the chat box.
So, like, what does pseudo-inverse mean? Does it basically mean inverse of a matrix?
No, it means a pseudo-inverse of a matrix.
Pseudo, in what sense, sir?
Okay. So have you gone through the videos? Because this is being explained over there.
I didn't understand this part in the video.
Pardon me?
I watched the video, but I didn't understand this part.
I see. So pseudo-inverse of matrices are required when, say, let's say we have a equation like so x w is equal to y, right? So assume that this is a mathematical equation. What we want to do is we want to find w. So what we do is we multiply it with inverse of x on both sides, right?
Yeah, so basically, it's an inverse, right?
It's
an inverse of a matrix.
yes, but x is not inverse of matrix is only possible when it is a square matrix, right? What happens if x is not a square matrix, and which is the real case? That happens very frequently in real world. X is not a square matrix. You have more number of samples than number of features, right? And for that we need a pseudo inverse.
We couldn't do it on paper, so there's a way to calculate inverse of rectangular matrix, right? Which can only be done by computers, not by humans.
Well, anything that computers can do can be done by humans, but it will take a lot of time. That's all, and patience. So beneath, so this is the answer, and actually I think one of Soumya has written her answer. Soumya, right? This is the correct one. So inside NumPy library, we use this API to get the pseudo inverse of matrix. And it's not difficult. We can see the procedure or the algorithm that this API is following to get the pseudo inverse. Not that we cannot do it. We can also do it, but it will be painfully long procedure. Okay.
Yes, sir.
All right. All right.
Why have you reshaped that array? Okay.
Well, if you
okay.
if you reshape the array, then you're not solving the original problem, right?
Right. No, in this I got it. Right.
Okay.
I didn't get it. So could you please explain why we are doing that reshaping?
That's not actually that's not recommended. We don't do it.
Okay.
Okay. Question number 7. Write a function that uses the concept of normal regression to find the weights of the model. The function should accept the feature matrix and labels. Okay. So this is directly taken from the lectures, the lecture content itself. Okay, I received answer from Soumya. Yeah, Soumya, this looks great. This looks okay. So this is the answer. I wouldn't take a lot of time for this because this is directly taken from the lectures and slides also. Pseudo inverse. So what is pseudo inverse basically? See, now we know that X is not a square matrix. So what we do is we do a mathematical trick to solve this kind of equation. Okay, so this is what we do. All right. So now X transpose X is bound to be a square matrix. Right. Now we can do the inverse of this new matrix X transpose X and multiply on both sides. And this is what we are going to do. Okay, so the left hand side will become something like this. This will be cancelled. And you get your weight vector W. So this is your pseudo inverse of any matrix X. Okay, so either you can compute it like this, write in NumPy library, X transpose whether it takes, then take the inverse of it and then multiply it by X transpose, you are going to get the same answer. Or you can just call P inverse, which stands for pseudo inverse. So see this one. This function is doing exactly that. The first the part of this statement, which is numpy.linearalgebra.env of X, computes the pseudo inverse and it multiplies it by the label, and that's your answer. That's your weight vector. Okay. So I would request you to run this weight vector. Okay. So let's compute this, right? We have Y and we have X also. So let's compute our W. So what is the mistake? One dimensional array is two dimensional. Reshape to -1, 1. Then we get W. Wait, I think we made a mistake. Yes, we did not add the dummy feature. So I should write it. X is equal to numpy dot column stack zero. I think now it works. There it is. Let's print the shape of X and Y. Now let's plot our the data points which are represented by W. The blue points, and our model which is represented by orange line. Now you can see that our orange line is doing a decent job, very good job of making the predictions. That means catching the underlying pattern. So you can see that the orange line is over the actually goes exactly in the middle of the data points. Hence, it's a very good model. It's a does it make sense?
Yes, sir.
Okay. Next one. So any questions so far? Whatever we have done. So basically, we are trying to follow the steps which are required in getting a solution to regression problem, linear regression problem. Any questions so far?
So, this one small doubt. I didn't. You wrote plt.scatter x comma y, and x comma x at the rate w. What's the difference between w and x at the rate w?
This one x and x at the rate w.
And y. Like, what's the difference between the two? Like, I got y doing this only. Like, what is this?
Yeah, sure. So xw is the predictions, right?
And y?
And y is the ground truth. So I should add the legend. ELT dot legend. I should add ground truth and predictions. Now the red line represents the sorry. How is it possible? They are interchanged. Predictions should come later. Okay. Okay, now it is corrected. So the ground truth points are the blue ones and the red is the R model, the predictions.
So what is ground truth? Like, I know this is y equals to mx plus c, but when we have a function, then why are we predicting? Like, there's no use when we already have a function. So why do we need to predict it using weights and all?
Because we don't know the model, right? Earlier so this is a very toy example in which we used some generating function which was y is equal to mx plus c. Where did it go? Something like this, right? This one, y is equal to mx plus c. We used underlying data generating process to be this one, right? But in real world data set, real world problems, you will just get I would say a data set. You wouldn't know the model. You wouldn't know the relationship between y and x.
So
Right.
ground truth will never be given to us.
Ground truth will be given to you. That's what you use to train your model.
What is it exactly?
Okay. So for example, I want to predict the marks of a student in coming exam. And I don't know the, of course, the exam has not happened, so I don't know his students' marks. But what I can do is I can see their past performance, right?
Yes, sir.
Right. So, for example, a student has consistently performed really well in mathematical courses. Then it is likely that he will perform better in the next course also, right?
Yes, sir.
So I can create a model to do this. Another example could be, let's say I want to predict the temperature of a city in a particular month or even on a particular day. And what I have is the temperatures which were there in the previous days, the humidity, and so on and so forth. The cloudiness, all the metrics I have. And all I need to do is make a prediction.
When you created the model, like for ground truth, then to know the weights for that model, you had to do gradient, descent, or normal equation, right?
Right.
So you went through the whole process of ML and to get that model, and to predict from there, you use the same process. So, okay.
Okay. So imagine that. Imagine that I have some data, and using that I have produced a model, right? Now new data comes in, and I want to figure out what should be the value for its what should be the label, what should be the current corresponding value. How would I do that?
You will like create another model.
No, I'll just reuse the model, right? I have already trained a model. If a new sample comes in, I will just make predictions. Is my point clear?
Yes, like you used normal equation like x at the rate w to create that.
Okay.
To know the weights.
Okay.
So they're different weights, right? Than the ground truth.
See, ground truth is a label. It's not weight vector. And see, the error is minimized. This model that we have got, the red line, it is minimizing the error. But error is not zero, even in this case.
Yes, sir. The ground truth doesn't have any weights. Then how do you create that model? Like, I just want to do that.
Okay, so if we have the ground truth, how we create the model, is it?
No. Like for ground truth, how do we create the model? Like from previous data, how do we create the model? Like it doesn't have weights, right? For, in ground truth.
Yeah. So whenever you receive the data set, you don't have any model. You don't have any weights. All you have is feature vector or feature matrix and label vector.
And from there, you create ground truth model.
No. I don't create ground truth model. Ground truth is actually my Y. The Y that came with the data set. I didn't do anything to ground truth.
But we have a formula like mx plus c.
That's true, but that's a toy example for which I have generated the data. When you receive real world data, you wouldn't get this kind of model.
Got it. Yes. Okay, sir.
Okay. And then your task will be to actually figure out the model. Okay. Going to next question. Write a function that accepts feature matrix labels. Now we are in the second phase of second part of the optimization. We have seen the normal equation method. Now we are looking at the gradient descent method. Write a function that accepts feature matrix labels, initial weights, and returns them new weights after one iteration. Okay, let's. Do you want me to solve this, or do you want to take some time and write in the chat box? Hello, am I audible?
So please solve it.
Okay, okay. So, so if you refer to the lectures, this is how your training process happens. So this function receives x, y, w, and the alpha. Alpha is the learning rate. And from the lectures, if you recall, this is your, what is this? Can anyone recall what does this quantity represent?
Derivative of loss function.
Fantastic. Yes, this is the derivative of loss function with respect to weight, and you multiply it with the with alpha, which is your learning rate. There is a negative sign because you want to move in the opposite direction, and whatever change we get, okay, from the initial weight vector, that's our answer. Okay, so this is the small amount of change that we want to make to our current weight vector, which is w. So w minus this derivative multiplied by alpha gives you the next weight vector, and then you can repeat this process iteration by iteration, and you can get the optimized answer.
Where is the learning rate in this?
Learning rate is alpha, this one.
Oh, okay.
Okay.
Okay. Yeah. So step one is, what was the question? It was given after one iteration. Okay.
Right.
For many, you will have to put a loop.
Yeah, yeah. For many, we will have to put a loop. So now we can visualize this also. So this question is trying, this next set of code blocks are trying to do exactly same. For example, we started with original W0, some random, which is represented by blue line. W in the orange is the optimized model, and W underscore iteration 1 represents the model after iteration 1. And now you can see that it has moved closer to our final answer, right? So iteration by iteration, it will improve and become, after a certain number of iterations, it will become the optimized model.
So can you take it a little above? Just want to see the code.
Yeah, yeah, sure. So I can run through it as well.
No, fine, fine. Okay, I just wanted to, yeah, it's fine.
Okay. So this code is explains how the loss function not loss function, yeah, how the loss function changes with the number of iterations is represented by this graph. So all you do is compute next weight vector with this learning rate and keep computing loss function. And at the end of it, at the end of the loop, what you do is you just plot the loss values inside the loss functions after every iteration versus the number of iterations, and that's it. You get the answer. So this represents number of iterations that you have taken, and this represent this list represents the value after each iteration of loss, and this is how it looks like. So it is continuously decreasing. Okay, does it make sense?
So the plot function, can you please explain that range of len of?
Yeah, sure. So see, losses is a list. Okay, and what I want to do is after every iteration, in 100 iterations, I'm computing the loss. Before I run this code, I compute the loss, which becomes 0th entry without any gradient descent iteration. What was the loss? Initial loss. And after 100 iterations, how does it look like? So after every iteration, I compute the weight vector with the help of this method. Then I compute the loss with this updated weight vector. It is supposed to be lower. In every iteration, it is supposed to be lower. And what I do is I'm appending the value of the loss in this losses array or losses list. Okay. So after this code block is executed, I have a list called losses, and from start to finish, whatever loss values I receive after every iteration are the values inside this losses list. Okay. So this is that list. Values, value of losses, a loss function after every iteration. And how many iterations were there? These many. Length of losses list. And I'm creating a range. I'm using a range function to create an array starting from 0, 1, 2, 3 up to length of loss list -1 in order to plot this.
So that weight you have not taken 0, 0. That's
yeah, you can take any value of weight vector.
You've just taken 15 and 14.
Yes, you can take it 100, 200,
yeah.
10,000, 5,000. It will still lead you to the optimized.
Right. But if we change this the learning rate to point say 0, 1, then we may not get this kind of a learn.
Right. Either if as you said 0.01, it might either
overshoot
your optima, or if it is still okay, then in even fewer you will see that the loss function is going to give you very small values, and without the loss function value will not change after a few iterations only. So right now it looks like after 15 or 18 iterations, the loss function did not change.
Did not change, right.
Yeah. So if it does not overshoot with 0.01, you might see loss function hitting a plateau. That's after 3 or 4 iterations or after 10 iterations. Okay. Any questions so far? All right. So let me stop sharing now. And I think we can conclude our session today. Sure, Aisha. I'll share this collab with everyone.
So I just want to thank you. This session was very helpful. Actually, the demo was so much of programming, but you made this really helped. It was so simple, and concepts have got cleared very much, at least the programming part.
Okay. Okay. Thank you, Vivek.
Hello, sir. Sir,
Yes, sir.
sir, I have doubt in slide. We have to slide. Can you explain, sir? I have doubt in slide number 44.
What was the topic of that slide?
Gradient descent, non-vectorized.
Gradient descent non-vectorized. Okay. Okay. I hope the screen is visible now.
Yes, sir. Yes. This is slide number 44. 44, sir.
This one. Yes. This one.
Yeah, sir. This one. Sir, how sir have find out this derivative of loss function with respect to W naught? How he got this? Can you explain this, sir?
Sure, sure. So, okay. So for that, you'll have to look at this some equation about. See this one, right?
Yes.
Imagine
Sir, yes.
this equation, right? So there was a square, and W0 plus W1x1 plus W2x2, and
Yes.
the series goes on, right?
Yes, sir. Yes.
Right. Now, imagine that quantity. So we had a half. So when we derive x square, something of square of something, 2.5 gets cancelled.
Yes.
We write the entire thing itself, and then the entire expression W0 plus W1x1 plus W2x2 up to WMX1 minus y is differentiated with respect to W0, and you'll find that there's only one quantity which has W0, which is W0x0, right?
Okay, sir. Yes.
And since x0 is constant for this this equation and this situation, we are differentiating with respect to W0. Therefore, differentiation of W0 x0 becomes x0 itself, right?
But sir, actually value of x0 is what? This is already 1 actually, no? This is already 1. X0 is already 1, sir. So
yeah, that's what is written over here.
So this is not after the derivative, but how he, sir, got this above expression, sir. Sir, I have written here value here. This is value of x0 is what? This is 1. But above equation, how he got? I can't understand this one.
Okay. Okay. Look at this second equation with respect to W1. Okay. Hello.
But sir, yes, sir.
So if you look at this this whole expression, okay, imagine that from W0, okay, it is not allowing me to select it properly, but imagine that you want to differentiate only this expression, W0 plus W1x1 plus W2x2 up to WMXM with respect to W1 only, right? Hello?
Sir, yes.
W1 only. Then you will find that only this second quantity has W1 in it, W1x1.
Yes, sir. Yes.
Okay, so derivative of that will become x1 and everything else will become 0, right?
But sir, actually, sir, this is derivative, na? Sir is not differentiating this again. They have written that derivative of loss function JW with respect to W1 is this summation of this.
Yes, yes.
He is not differentiating this again. Can you scroll
Yeah.
up, sir? Then can you
Yeah, we are
scroll
not.
up? Little up, little. Now, sir, now stop here. Stop, sir. Now look here, sir, how you have find out. Here is a derivative of loss function with respect to W. You have taken common X transpose. Okay, sir.
Where have we taken X transpose common?
X transpose common, then this will be
second
W
equation.
minus Y.
Yes.
So X is actually feature matrix. Then he have multiply feature matrix with W.
Right.
I understood this one, but this X transpose, if he have differentiated this X transpose with did W, then how he got their X not? I am unable to understand this actually.
Okay, this one is different than this one, right? In this one, in this equation, every W0 X1 you are seeing, they are
Actually, sir,
scalars.
I have expanded that. Actually, what is this? W0 plus W1 Xi. This is actually W XW. This is XW actually, sir. This is multiplication of feature matrix with X feature matrix with W.
Okay.
And how he got here X not? I am unable to understand this one.
X not I. Okay, so okay. First of all, see this equation and this equation, they are exactly same. One is written expanded version, another is written in matrix or vector format.
Yes, sir.
Okay. So let me write something in maybe the Okay, so imagine that your y is W0 plus x1 minus y.
Okay,
there should be I over here.
Yes.
Sorry, this is your loss, not.
Yes.
Okay.
Yes, sir. Yes.
Now you differentiate with respect to W0 only.
Yes.
Then what will happen? The JW EW naught.
Yes.
This will become 2. See, this is a quantity for summation is going to stay exactly same, right? I'm
Yes,
not going
sir.
to change that.
Yes.
This quantity we are going to differentiate. So we write half already, right? So half is there. This 2 will come over here.
Yes, sir. Yes.
The exact quantity W0 plus W1 X1 is per I, not power I, superscript I minus yi. Now you have to differentiate this quantity and put it over here, right? So if I differentiate this with respect to W0, what will I get?
This will be one only, one here.
Only one, right?
Yes, sir.
This 2 gets cancelled.
Yes.
So this is the quantity which is written on the slide, right?
Now got it. Sir, now I got it. Thank you, sir.
Okay.
Oh my God. When I differentiate again, sir, with respect to W1, so this will be Xi.
Exactly.
Yes, sir. Thank you, sir. Thanks a lot.
Okay. Okay, thank you everyone. Any further questions? Okay. Thank you, everyone. Thank you for allowing me to extend the time a bit. Have a good night. It was a great session.
Thank you, sir.